Yeah, today we'll start this MOSFET to operate in next. So last class I told you it is operating in three regions. One is cutoff region, and next one is linear
Yeah.
region, and non-linear region, and next is saturation region. Okay. Today we discuss about this saturation region. So what is this saturation region? I think my screen is visible. One second. Uh, okay, my screen is visible now. Yes.
Yes, sir.
Okay. Okay. So now we'll discuss the N-channel MOSFET. That is in which region? So that means MOSFET. So MOSFET is in linear region. Okay. Next region is we are discussing about this uh, N-channel enhancement MOSFET. Okay. N MOSFET. Okay. So MOSFET in linear region. Linear region. Okay, MOSFET in linear region we'll discuss. Okay, so here operation of what this is, we are discussing an enhancement n channel MOSFET. Enhancement n channel MOSFET. So enhancement n channel MOSFET means what? Channel does not exist. Okay, channel does not exist. We need to develop the channel by applying uh, some positive voltage, so that whatever the minority carriers are there in the p-type substrate, that will be accumulated in the surface of the substrate, and that will be available. Okay, so what is the condition for linear region? You are applying some gate to source voltage that is greater than Vt. Okay, and VDS also you are applying. VDS, drain to source voltage, you are applying 0, and such a way that VDS should be what? VDS should be less than VGS minus VT. VGS minus VT. Okay, so here what happens? I am drawing the diagram. This is uh, P substrate, and N plus N plus. Okay, and oxide layer. Once again, this is oxide layer. Okay, SiO2 layer, and polysilicon. This is polysilicon. Okay, or metal, polysilicon or metal. Okay, polysilicon, and here this is a metal, this is a metal, and this is a metal. Okay, so here you are applying source to ground. Okay, and you are applying small amount of gate to source voltage. Okay, VGS, this is gate, and this is source. So gate to source voltage, you are applying positive voltage. Okay, so you are applying positive voltage, so with respect to source. Okay, so VGS is what? Greater than VT. VGS is greater than VT, and VDS also, small value of VDS you are applying. Okay, small value of VDS. So this is drain. You are applying small value of VDS. This is VDS. VDS is greater than 0. So due to this, what happens? Electrons will be accumulated, and electrons will flow from where? So here this is the channel area. Okay, so electrons will flow from where to where? Source to drain. Electrons will flow from where to where? Source to drain. Okay, source to drain. So why? Because you are applying some positive voltage, whatever the minority carriers are there, that will be attracted, and here with respect to source, you are drain to source, you are applying some positive voltage. Okay, so from positive voltage, with respect to here, you are applying negative. So negative means what? Here whatever the majority carriers are there, that will be repelled, and from this the electrons will be attracted, and that will be attracted towards drain. Okay, so the flow of movement of these electrons are from source to drain. What is the conventional current? Conventional current, the current will flow from where to where? Drain to source. Current will flow from drain to source. This is nothing but IDS. So this approach, this one we call as what? ID. Okay, so So channel is what is the nature of the channel? Channel is uniform. Okay, so that means channel is uniform. Okay, here I am applying VSB equal to 0. VSB equal to 0. Okay, so here I can write during the linear region, as VGS is greater than VT. Okay, so last class we already seen that is strong inversion layer. Strong inversion layer, there is a threshold voltage, that is a minimum gate to source voltage to form a strong inversion layer. So the strong inversion layer, what happens, the number of electrons in the surface of the substrate, that should be equal to the number of holes in the p-type substrate. That is nothing but we call as channel, or we can call as a strong inversion layer. So when the channel will form, so this is the condition, when VGS is greater than VT, channel will form. Channel forms. Okay, this is the condition, channel forms. And as VDS is greater than 0, okay, for small value of VDS, for small value, not larger value, small values of VDS, small values of VDS, what happens, here there is a potential difference exists between where to where, drain and source. Okay, there is a potential difference, potential difference. Okay, potential difference exist between source and drain, source and drain. So what is the, so how you can correlate this potential difference? Suppose like if you consider any pipe is there, so pipe when you are keeping like horizontal, okay, horizontal, so when you are pouring some water into this pipe, some water will flow, but some water will be remaining in this pipe. Okay, suppose this same pipe, if you tilt something like this, whole water will flow from this end to this end. Okay, so like that, there is a potential difference you are applying across where to where VDS. Okay, so due to this potential difference, what are the electrons? Electrons are there, electrons are flowing from source to drain. So when the electrons are flowing from source to drain, there is a drain current. Okay, so due to this potential difference, what happens, whatever the electrons are there, whatever the electrons, okay, electrons flows from source to drain. Okay, source to drain, electrons will flow from source to drain. Okay, you have a conventional current. What is conventional current? Suppose we already seen, suppose electrons are there, electrons are flowing like this. What is the conventional current? The current due to these electrons is opposite to the direction of the electrons, opposite to the direction of the electrons, that we have already seen in the semiconductor physics and PN junction diode. And suppose if you consider the holes are there, holes are moving from left to right, the current due to holes is same as the direction of holes. Okay, here channel is forming due to what? Electrons. Okay, that's why we call as what? N channel. Okay, N channel, channel is forming due to what? Electrons. Okay, so here what happens, either electrons are flowing, okay, ID exists, there is a current exists. In cutoff region there is no ID. Why? Because there is no flow of electrons from source to drain. Just in cutoff region, ID equal to 0 only. Okay, you are not applying any VGS and VDS. Okay, so just we are getting ID equal to 0. Okay, in linear region ID exists, ID exists, that is conventional current. Conventional current. What is conventional current? That is the current opposite to the direction of the electron. Okay, that is current, that is direction. How the current will flow, as electrons are flowing from source to drain, the current ID will flow from drain to source. Drain to source. Is it fine? Do you understood the operation of this linear region? Yeah, give response. Shall I move forward?
Yes, sir.
Okay, and next, so next what happens, here I'll draw one more time. So this NMOS in linear region. So here what happens, so This is n plus SiO2 layer, polysilicon and metal. This is also metal. Okay, and this one is substrate, p substrate. Okay, p substrate. Here this is source, gate and drain. Okay, source is connected to ground and drain is connected, gate is connected to positive with respect to source. Okay, and this one VDS with respect to source, so this is also positive. Okay, this is also positive. Due to this, what happens, channel is forming. Okay, so what is the condition we already seen? That means here VGS is greater than VT. Okay, channel is forming, and VDS is greater than 0, and VGS is what? VGS is less than VDS, such a way that VDS is less than VGS minus VT. VGS minus VT. Okay, so here what happens, as VDS increases, okay, and constant, you are making constant, and VGS is what? VGS is greater than VT. Okay, greater than VT. Further increase in VGS. Further increase in VGS. Okay, if you increase further, what is that voltage? Positive voltage. Okay, if you increase further, one second, this is positive voltage. VGS is positive, no? So this is negative and this is positive, and this is positive, and with respect to source, this is negative. Okay, due to this, ID current is flowing from drain to source. Further increase in VGS, what happens? More electrons will be accumulated in the channel. Okay, more electrons will get accumulated in the channel, and the depth of the channel increases. Okay, channel will be linear only, the depth of the channel, so the depth of the channel will increases. Okay, so that's why we call as what? Enhancing. Enhancing is nothing but what? So enhancing is nothing but increasing. Okay, as further increase in VGS, there is a depth of the channel increases. That's why the name called enhancement channel. Okay, so further increase, so that means as you increase VGS further, okay, as you increase VGS further, depth of the channel increases. Okay, depth of the channel increases. Okay, depth of the channel increases. That's why enhanced channel. Hence, so enhanced channel means what? Increase in the channel. Okay, enhanced channel. Okay, you search what is the meaning of enhanced channel. That is nothing but increasing only. Enhanced channel. That's why the name came, means that's why we call as enhancement MOSFET. Enhancement MOSFET. The depth of the channel is depending on the applied gate to source voltage. Okay, applied gate to source voltage. Okay, so how much it will increase means there is a overdrive voltage. What is the overdrive voltage? That is VGS minus VT. This is nothing but we can call as VOV. VOV is nothing but what? How much this depth of the channel is increasing means this is increased to an overdrive voltage, that is VOV, that is equal to what? VGS minus VT. VGS minus VT, overdrive voltage. Okay, so so that means here as VGS over VT gives the enhanced channel. Okay, enhanced channel. So that means as ID number of electrons increases, so as the number of electrons increases in the channel, so depth of the channel is increasing means what? Number of electrons are increasing. Okay, that channel is coming towards this p-type substrate. As the number of electrons are increasing, what happens? ID also increases. Okay, so why the name came means you need to tell like this. As VGS is more positive, okay, channel will enhance, the depth of the channel increases. That's why the name called enhanced channel, and that's why the name came enhancement MOSFET. Okay, is it fine? Do you understood why it is the enhancement MOSFET?
So what is this overdrive voltage you said?
Overdrive voltage means there is some potential, no, for this channel. There is some potential. How much depth it is increasing means this is based on the overdrive voltage. VOV. VOV equal to what? VGS minus VT. VGS minus VT. That is overdrive voltage. Overdrive voltage. VGS minus VT is nothing but overdrive voltage. How much depth it is increasing? That is nothing but VOV equal to what? VGS minus VT. Understood?
Yes, sir.
Okay. Next you see. So next here yes. So here what happens? I need to see the nature of this MOSFET during the linear region. So what is the condition? VGS is greater than VT and VDS is greater than 0, small value, okay. You are giving a small value, and VDS should be such a way that VDS should be what is less than VGS minus VT. VGS minus VT. Okay. So here what happens? One more time I will draw. So this NMOS in during nonlinear region, linear region. So this is N plus, and this is N plus P substrate. Substrate. So here VSB equal to always 0. VSB is connected to ground. Okay. So here this source is connected to ground, and this is oxide layer, and this is polysilicon, and this is gate. You are applying positive voltage with respect to source. Okay. So this is gate, this is VGS. Okay. And here this is metal you have. Okay. Here also you have metal, and in this you are applying positive voltage. This is VDS. Okay. VDS. So there is a ID current flowing from where to where? Drain to source. Okay. So here what happens? So there is a channel, that is uniform channel. Okay. Channel will increase. Okay. So channel exists with certain depth. How much of certain depth it will be exist? I told you overdrive voltage, no? Overdrive voltage. What is the overdrive voltage? VGS minus VT. Channel existed with a certain depth, that is VGS minus VT. Okay. Due to potential difference, there is a electric field increases due to potential difference. Okay. Due to some potential difference. Potential difference means is what? You are applying some VDS, no? You are applying some VDS. Okay. Due to this VDS, there is some electric field. Okay. Electric field is developed from this drain to this channel. Okay. Drain to this channel. Due to this there is a drain current. Okay. Drain current. Okay. So here during this ID increases as VDS increases. ID increases as VDS increases. Okay. So channel, so that means the channel is uniform. What is the nature of the channel? Channel is what? Channel is uniform. Okay. So when the channel is uniform, it's behave like what? It behave like a resistive component. Okay. Channel behave like a behaves like a resistive component. Okay. So like a resistive component. So resistive component means we already seen the Ohm's law. What is Ohm's law? So that means V equal to what? IR. Okay. I equal to what? V by R, no? V by R. Okay. So that means here if you draw the voltage with respect to current, you will get the like straight line. This is the slope. This is nothing but 1 by R. Okay. So that means current is linear. What is that current? ID is linear. ID is linear. Why? Because channel is uniform, and as the channel is uniform, that channel will be act as a resistive component. So as this is resistive component, ID increases as VDS increases. ID increases as VDS increases. Okay. So channel is acting as a resistive component means it is acting as a current becomes linear. Okay. ID becomes linear. Okay. So that's why we call as linear region. Okay, that's why we call as what, linear region. So in this I can draw the curve. Okay, so what is linear region? Did you understood this one? Any doubt in this?
Yes, sir.
Okay, so channel is linear,
Yes,
that's
sir.
why we are calling as linear region. Okay, so channel is uniform and it is acting as a resistive component. Okay, so here if you draw the characteristics in the linear region, so how the characteristics will look like, so if I draw the this is drain characteristics, this is nothing but drain characteristics. So drain characteristics, what is the drain characteristics? I need to draw VDS. VDS is nothing but output voltage with respect to output current. What is output current? Drain current. Output current. Okay. So here there is small amount of current is there. So this current is what, VGS is less than VT. VGS is less than VT. Okay. This is nothing but what, formation of weak inversion layer. We already seen, no, in the cutoff region, when the number of electrons in the surface of substrate is less than the number of holes in p-type substrate, that is nothing but we can call as weak inversion layer. Okay, in weak inversion layer channel is not forming, just inversion layer is forming, but channel is not forming. Channel is forming in the strong inversion layer. Okay, so as so that means as VGS increases, okay, more than VT, so more than VT, suppose here you see, so as VGS 1 is greater than VT. Okay, so here as VGS increases, drain current also increases linearly. Okay, and this is linear. Why? Because channel is uniform. Okay, as VGS increases more and more, what happens? Whatever the minority carriers are there, that will be added in the channel. Okay, that will be added in the channel. Drain current also increases. Depth of the channel increases, number of electrons in the channel increases, so drain current also increases. So from here you can say that this is one more voltage. This is let us take VGS2. VGS2 is greater than VT. VGS2 is greater than we can call as VGS1. Okay, this is nothing but VGS1 is greater than VT. This is nothing but what, formation of strong inversion layer. Okay, strong inversion layer, or we can call as what, channel. Strong inversion layer is also called as what, channel. Okay, and what is the condition? Number of electrons in the surface of substrate is equal to what, number of holes in p-type substrate. Okay, so this is the strong inversion layer. Weak inversion layer is number of electrons in the surface of the substrate is less than the number of holes in the p-type substrate. Okay, so here ID increases. So that means from here I can say that as VGS is greater than VT. Okay, VGS is greater than VT and constant. Okay, Okay, VGS is greater than VT and constant, and you are increasing VDS. VDS is a greater value. Okay, greater than 0, and smaller range is there. Smaller range you are increasing. Okay, smaller range you are increasing. Smaller value if you are increasing, current increases linearly. Why? Because channel is uniform. And it is acting as a resistive component. So we know that for the resistance, current and voltage relation both are linear only. So that means as VDS increases, this ID also increases. How it is increasing means linearly. Okay. This is about linear region. This is about linear region. Yeah. Any doubt in this linear region? Give response.
No, sir.
Okay. So MOSFET linear region. Okay.